Okay, now we're finally coming to the point where we're introducing what FrogNet memory really is and talking a little bit about how it works. We've already had an introduction to the database that we're using because that's where we store the template information, where we store the cache, right? It's a MySQL database, so it's part of the LAMP stack, right? LAMP, MySQL, and we're actually using PHP in many cases to access it and to talk to it, right? So that's the way that we're supposed to be doing this stuff, and that's the way that we do it. Um, the concept of making that a network-wide uh, system is something that sort of I don't know how it came to me, but it just kind of did. I said, I need a network-wide database, right? And I said, well, so I've got stuff like SQL Server and things like that I can set up, but those require administration and they're deterministic and all that kind of stuff. And I said, so what if I had an IP address that was the network-wide database, the canonical database? And I said, well, that's pretty cool. That would kind of work, I think, but it wouldn't have memory. What do you do when you switch it, right? How do you, and this is the same discussion I'm sure a lot of you have had, right? How do you have continuity? And I thought about that for quite a while. And then I kind of said, you know what? We don't need continuity. We don't. It's data. If we look at it as a single point in time, if we look at it as something that is it's just there, right? It's either there or it's not. And if it's there, it has maybe a timestamp. It's got something else. But the way the decision that something is stale or not is not mine. It belongs to the application that's reading it. And even the definition of what is stale is not mine. It belongs to somebody else. So if I look at it as a single point in time, not anything that I'm going to put any historical data into, now I have a message exchange point, right? Now I have a place where I can write something and have something else somewhere else read it and not have to worry about writing messaging code to go out and get it. And I thought about it a little more, and I kind of went, that's memory. That is the definition of memory, right? A single point in time, something writes to it, and other things read from it. And when I saw that, when I realized what it was, a lot of things clicked in because it meant that we had really, we had successfully raised the programming surface, which heretofore had been a local machine with uh, ways that you can transfer data between networks to a single network shared memory, right? And that was the thing, right? I can make it work across more than one network, and I can make it work across the internet, right? Because it is just an IP address, right? So the database host became an IP address. It became an entry. And whenever I needed to do something with the database, I just called database host. And the merge process at the very end of it sets database host. That's the last thing that it does. Originally, I'd set database host to be the highest IP address in the land. And that worked for a while. But then I got to thinking about it, and I said, that's probably not the best place, not the best thing to do, because I was looking at some of the things that we were doing with it. And I realized that many of you probably have, hot little boxes that you really want to do database work, and something like a Raspberry Pi doing a MySQL thing is probably offensive to you, and I don't blame you. um, it works, but yeah, it's probably not the slowest. It's probably not going to scale to enterprise level, all that. There's no argument there. But how do I do that? How do I set you up to do that? And the answer came in the form of uh, a role, right? And that's what we developed, is these roles. So database host is a role, and media host is a role, and the game host is a role. And the roles have elections, and the roles are part of the whole factory pattern kind of thing. So the role has a component that fits within Apache, that fits within the, not Apache, but fits within the proxy, so that the proxy understands what it is when it sees one of these messages come through, and it can notify the right things. Uh, but really, it comes down to what happens when the database host switches, and how do you define what the right requirements for the machine host are, and things like that. How do you tell the system what the IP address of this service host is going to be, and then what needs to run on every single machine? Because by definition, if you become your own machine, if you become your own sole network, then you're the one who has to run that role, right? Either that or you disable the role. But whatever it is, these are the decisions that have to be made, and they're made on a per role basis. So the whole role thing was extended to become more generic than that. And along the way, the transient database, that's what I called it, became the control database. So there is still the control database, and it's still defined by the highest IP address in the land. But the only thing that's written into that database are the capability tuples of the individual machines as they come up. And so they write into the database, what their configuration is, what they have software loaded, all that kind of stuff. And then when the merge gets done, it takes a look at the capability information that's stored, and that's how it decides what services to go up. And that's that's the first and most important role. But it kind of it makes the memory, right? We define the database host based on the capabilities of the system, and everybody does it deterministically based on the information base contained in the control database. So everybody arrives at the same IP address on the network. And if you become your own, or you join a new one, then you have a new set of data that you use, right? You have a new control database, and everybody starts getting their data from it. You deterministically decide who's what, and you have a new database host. So having the database host there all the time, which is what you do, uh, means that you will always be able to have that memory available to you. And any machine on your network, any program on any machine can get to it. It is just it is accessed through a regular REST API, just like anything else, and it is controlled by what we call tuple space. And tuple space is what I will talk about in the next video. So hopefully you have an idea now of what the FrogNet shared memory is, and how the transient database works, and how it's selected as the machine, as the network reconfigures itself, and as the system discovers what it needs to discover, so that the network is consistent, right? It's there's no magic. It's just figuring out who goes where and when, and it's really pretty straightforward. But what you end up with is actually network shared memory, and that's where we're going to leave this one. So have fun.